This is Prabha Verma here with my next video of class 9th mathematics. In my previous video, I have already discussed the remainder theorem, through which you learned to find the remainder without undergoing the process of long division. Now moving a step further, what I'm going to discuss over here is the application of this remainder theorem. But before I move on to discussing a polynomial in this, let me just discuss it with normal numbers. Now when you talk about the terms factors and multiples, what do you mean by that? If I take a simple number as suppose I take as 24, right? I take the number 24. If I ask you to divide it by 3, obviously when you divide it by 3, 3 goes 8 times, 24, you get the remainder as 0. So when I perform the process of division over here, I got the remainder as 0. So in such a case, we say that 3 is a factor of 24. That means the smaller number is a factor of the larger number. When does this happen? It happens only when on dividing you get the remainder as 0. Another way of saying this is that 24 is a multiple of 3. Another way of saying the same thing is 24 is a multiple of 3. So if I have to say it in a general way, whenever you are asked to check some number, a smaller number is a factor of the larger number, or the larger number is a multiple of the smaller number, in either of the cases, what you have to do is you have to perform the process of long division. And when you perform the process of long division, if you get the remainder as 0, it is a factor oblique multiple. If you do not get the remainder as 0, it is not a factor or a multiple. Like for example, if I take 22 divided by 5, 5 fours are 20, I get the remainder as 2. Now in this case, I did not get the remainder as 0. So obviously, neither 5 is a factor of 22 nor 22 is a multiple of 5. And always remember, factors are smaller and multiples are larger. Now applying the same concept in polynomials, I come down to this question where it says that check whether 4x cube plus 4x square minus x minus 1 is a multiple of x plus 1. Now I've been given two polynomials over here. As in every question I say, I've been saying repeatedly, the first step in a question of polynomial is you name your polynomial. Now between the two given polynomials, obviously one is of a higher degree, this is of degree 3, and this is a degree 1 polynomial. So I named the polynomial with a higher degree as px. So my px becomes 4x cube plus 4x square minus x minus 1. And I named the polynomial with a smaller degree as gx. Now like in case of numbers, the bigger number is a multiple of the smaller number and the smaller number is a factor of the larger number. The same logic applies over here, but with a slight difference. Here, bigger and smaller, we talk in terms of degrees. So the polynomial with a smaller degree is called as a factor of the polynomial of larger degree, whereas the polynomial with larger degree is called as the multiple of a polynomial of smaller degree. Now here also you have to check whether the larger degree polynomial is a multiple of the smaller degree polynomial. As over here also you will have to perform the process of division to find the remainder. Now you can either solve this question by doing the process of long division. If you do not want to do that, you can directly apply the remainder theorem over here to find the remainder. So to find the remainder over here, what did I tell you earlier? You will find the 0 of, first of all, gx. So I get x plus 1 equal to 0, or I get x equal to minus 1. So the remainder becomes what? The remainder becomes p of this minus 1. This is what I explained in my previous video. So this is how you find the remainder. You take the smaller polynomial, find it 0. Whatever value you get, replace it everywhere in px by that value. So p of minus 1 becomes 4 to the power of minus 1 whole cube plus 4 to the power of minus 1 whole square minus of minus 1 minus 1. On solving this, minus 1 to the power of 3 gives me minus 1 and minus 1 into 4 gives me minus 4. Minus into minus becomes plus, so plus 4. I get minus into minus as plus, so I get plus 1 and I get a minus 1. Am I clear? I replaced x everywhere by 1. So this becomes minus 4, this becomes plus 4, this becomes plus 1, and this becomes minus 1. Everything gets cancelled out. I get the remainder as 0. So here you will write, since remainder equal to 0, therefore px is a multiple of gx. Whether the question asks, check whether it is a multiple or check whether it is a factor, either of these cases the step remains the same. The steps remain the same. It will be a factor or a multiple only and only if the remainder comes as 0. If the remainder doesn't come as 0, then you will write the answer as, since remainder not equal to 0, therefore it is not a multiple or a factor. So this is a very important question. This comes as a 3-marker question. Now moving on to another important topic of class 9th from polynomials is the factor theorem. It is almost an extension of your remainder theorem. Now if I have any polynomial px and I take a as any real number, when I say a real number, it can be an integer, it can be a whole number, it can be a natural number, it can be rational number, all of these numbers. So a can be any kind of a number. So now the factor theorem has 2 conditions. The first condition says that x minus a will be called a factor of px if in the polynomial px I replace x by a and I solve it, I get the remainder, I get the value as 0. And secondly it says if p of a is 0, then x minus a is a factor of px. Let me explain this through a very easy example over here now. Now over here in this example, again I have written, check whether x plus 2 is a factor of x cube plus 3x square plus 5x plus 6. Again I have named the polynomial of higher degree as x cube plus 3x square plus 5x plus 6. The smaller one as x plus 2. I again find 0 of gx. So I get x plus 2 equal to 0, or I get x equal to minus 2. Next I again find the remainder. Why I am finding the remainder? Because over here only it says you have to check it that way. So it becomes p of minus 2. Wherever I have x and p, I replace it by minus 2. So minus 2 whole cube, 3 into minus 2 whole square, plus 5 into minus 2 plus 6. Minus 2 to the power of 3 gives me minus 8. Minus 2 square gives me 4, and 4 3s are 12. I get plus 12. Minus 2 into plus 5 gives me minus 10, and this gives me 6. Now minus 8 minus 10 gives me minus 18. Plus 12 plus 6 gives me plus 18. So the answer is 0. So since r equal to 0, therefore gx is a factor of px. So am I clear? Whether you have to check for a multiple or you have to check for a factor, either of the cases the method remains the same. Now there's another application of this factor theorem in another form. Here I have a second kind of a question which is written that find the value of k if x minus 1 is a factor of this given polynomial. Now as in every question, the first step is I have named my polynomial as px, the other one becomes gx, right? Now it says it is given in the question that x minus 1 is a factor of px. What did I do over here? Since x plus 2, what did you prove in the end? You proved that x plus 2 is a factor of px, right? And how did you prove that? You proved that because p of minus 2 was coming as 0. So same thing over here. Since x minus 1 is a factor of px, so therefore when I replace in p, now here if there is a minus sign, you will write a plus 1 over here. Here if there is a plus sign, you will write the opposite sign over here. That means whatever is given as a factor, you will change the sign of the number that is there over here. So whatever sign is there, since I have a minus sign here, I will write p1. Had there been a plus sign here, I would have written p of minus 1. So since x minus 1 is a factor of px, therefore p of 1 should be 0 by the factor theorem. Because for it to be a factor, this is a condition by the factor theorem. So now I find out p1. What is my p1? Here I replace all the values by 1. So 1 cube plus 3 1 square minus 4 into 1 plus k equal to 0. This writing equal to 0 over here is compulsory. So this becomes 4 plus 3 minus 4 plus k equal to 0. This gets cancelled out. So I am left with 3 plus k equal to 0 or k equal to minus 3. Is that clear? So when you have to find the value of any, it can be k, it can be written as a, k, a, b, c, anything. If you're given this is a factor of the given polynomial, you will find the remainder changing the sign over here. If there is a minus sign, you will put a plus. If there is a plus sign, you will put a minus and you will equate it to 0. Why equal to 0? Because it is a factor. Whenever it is a factor, this will always be equal to 0 by the factor theorem. You will solve it and you will get the value of k. Thank you.